Welcome to Chapter 5, Section 3. This one is on rates, and our central question is, how can you use rates to describe changes in real-life problems? Our key idea in this section, 5.3, is rate and unit rate. So we have three different vocabulary terms in this section. One is rate. A rate is a ratio of two quantities using different units. Unit rate. And a unit rate compares. I have a typo on there. Should be a unit rate compares, not the word is. So I'm gonna cross that off right now. Gone. Look at that. So a unit rate compares a quantity to one unit of another quantity. And then equivalent rates have the same unit rate. So again, as we always do this when we talk about vocabulary, you'll understand it when we put it into use coming up. So here's my beautiful drawing of pizza. So there's 3 pizzas. You paid $27 for all 3 of them. Well, my rate would be $27 to 3 pizzas. Now notice how we kept this as a ratio. So this is the rate I'm talking about, is my ratio of pizzas. And then my unit rate, there we go, would be $9 to 1 pizza. So that kind of gives you an example of what a rate and what a unit rate means. Unit rate meaning, if you think about the word unit, it means 1. So you can say, we're making the ratio that's representing one of the units, and well, when we're talking about units, we're talking about how many pizzas we have. In thinking about this problem, I didn't show you how to do the math, but if you think about it, all I did was I divided the rate. So I took 27 and I divided it by 3 to equal 9 to get my unit rate. So you start with your rate, and then you get your unit rate of 9 in this situation. So looking at it algebraic, you can see all I did was divided. I divided the rate, and I got a unit rate out of it. We would have, oops, that's supposed to be an A units, because we're not sure what it is. This is just speaking generally, to B units. I guess that looks like this is separated. It's not bunnets, it's B units. And this would represent our rate, where our unit rate, algebraically, would be represented as, it could be A over B units to 1 unit. Now what I mean by that, if you look back at the previous slide, so they're showing you to divide that rate, you get a unit rate. Example 1 is writing a rate. Example 1 is writing a rate. So the example they give you is they say the double number line shows the rate at which you earn points for successfully hitting notes in a music video game. Write a rate that represents, oh, that does not say represents at all. Write a note rate, let's see here, represents this situation. Okay, so you get a number line, a double number line like this, and basically what they're telling us is that we have the top part of it, these are our points that we get. The bottom part of it are our notes. So if you hit 5 notes, you get 750 points. If you hit 1 note, you get 150 points. You hit 3 notes, you get 450, and so on. So the question, the example that we're doing is saying writing a rate. If we're writing a rate, one possible rate that we could write would be something like this. We could focus on this. So it would be written like this: 600 points for 4 notes. That's one possible one. Another one would be, we'll do this one, 150 points for 1 note. And it is really just that simple. You look at it, you read it, what does it represent? 750 points for 5 notes, 300 points for 2 notes, 450 points for 3 notes, 0 points for 0 notes. It's really that simple. That's example 1. Example 2 is called finding a unit rate. So this time we're going to take and kind of learn how to do use a ratio table to divide and find an equivalent rate. So the problem says a piece of space junk travels 5 miles in 8 seconds. How far does it travel per second? Space junk is a picture right here. Kind of weird. I know they're using some kind of weird ones lately, but space junk is basically anything that falls out of the sky that is something that we know. So this one right here is actually a bundle of like metals and wires and stuff that have built up over time in our orbit and has fallen to Earth. So that's what space junk is, if you're like, okay, that doesn't make any sense. But anyway, so now let's focus on what we're talking about here. So a piece of the space junk travels 5 miles in 8 seconds. How far does it travel per second is what the question is asking us. So we're going to use a ratio table and divide by 8 to write an equivalent rate in which the time is 1 second. So what we know is we have a ratio of 5 to 8. So 5 miles to 8 seconds. So we know that our distance, being 5 miles, travels every 8 seconds. So in order to find out and get to where we use the ratio table and divide by 8, and to find out how many miles or how far it travels per second, we're going to write that equivalent rate. So here we go. So they're telling us to divide by 8. If I divide by 8, the reason I know that is because I already know that I'm going to get to the 1 that they're telling us to get to right here. And they're asking us right here, how far does it travel per second? Well, 1 is per second. So we know this has to be 1. That's what the story problem right there told us. This has to be 1. We know when we get from 8 to 1, we had to divide by 8. You've all learned in the previous section that if you do and divide by that on the bottom, you have to do it on the top. Divide by 8. Well, you might say, well, 5 divided by 8, that doesn't make much sense. Well, it does. You can make it a fraction. 5/8, right? 5 divided by 8. We don't want to make it a decimal. We can just say 5/8 in this situation. So the rate 5 miles to 8 seconds is equivalent to 5/8 mile to every 1 second. So we can write that out using what we learned in 5.1 by using a sentence to describe what we're talking about. So pretty much the space junk travels 5/8 mile per second, and that's what we just solved, and that would be the answer to my question. Remember, the biggest thing here is going with what they gave us. They gave us a rate for 5 miles to every 8 seconds. They want to know how far does it travel per second. They don't tell us 1. We need to know that per second means 1. Okay, and that's where we got our 1 from. If we want to know in time in seconds is 1, we write that 1 in there. Then we distinguish and we say, how do I get from 8 to 1? This is where we find our pattern. Well, the only way to get from 8 to 1 is to divide it by 8. If I do it down here, I have to do it up here. So that's how I'm finding out what I'm getting. So fraction-wise, if it's a lesser number divided by a larger number, you can make it a fraction. And that would be our answer, 5/8 mile per second. There will be some on your own problems that you can view after this, but I'm going to move on to example 3 from here. So for example 3, we're finding equivalent rates. And part A, there's 2 parts to this one, but part A says, a chef buys 6 pounds of salmon fillets for $51. How much will the chef pay for 9 more pounds of the salmon fillets? So basically, they go and buy this amount, and now they want more, but they want to know how much it's going to cost them before they actually buy it. So this happens in a lot of restaurants and things like that too. So for this one, we're going to use a ratio table. We're going to divide to find the unit rate and then multiply to find the cost for 9 pounds of salmon fillets. So when you're making your ratio table, you really have to think about it. what are the two things that I'm going to actually be writing here? How did I get cost? How did I get salmon? When you look back up at your story problem, and it says you have 6 pounds of salmon fillets for $51. How much will the chef pay? That's a key word, is pay, for 9 more pounds of salmon fillets. So we're talking about pounds. Those are where I get my two units for my ratio table. So I have cost in dollars, and I have salmon in pounds. As you can see, they already gave me my first ratio that I start with. It cost, let me get my pointer, cost $51 for 6 pounds of salmon. So now we need to divide to find the unit rate and then multiply to find the cost for 9 pounds of salmon fillet. Think about this question. Why would we want to divide it down to a unit rate? Why would that be necessary for what we're doing? Let me get my pen here. We know that we need to figure out what 1 pound of salmon is in order to find out what 9 pounds. Because the 6 and the $51 isn't telling us any information that we're going to use to be able to find out what 9 more pounds would actually cost. So with that being said, I have to figure out how to get to 1 pound. That 1 pound is really, really important, because if you don't find out what 1 pound equals, you're not going to be able to find out what 9 equals. We only know what 6 equals. So, how did I get from 6 to 1? Well, you divide by itself. Anything divided by itself equals 1. 6 divided by 6 equals 1. Well, I have to do the same thing on the top that I do on the bottom. Now, if you're at a point where you have to go over and say 51 divided by 6 and write it out like this, then you might have to do so. So again, asking yourself, how many times does 6 go into 5? It goes in there 0 times. How many does it go into 51? It can go in there 8 full times. 6 times 8 is 48. So you should have 3 left over. And that is where you're going to end up putting a decimal, because you're adding a 0. Okay, bring your 0 down. How many times does 6 go into 30? 5 times. So over here, 51 divided by, and I could do this math too, I forgot to do that. So I end up with 0. How many times does 51, can it be divided by 6? Well, it can be divided 8.5 times, or 8 5/10 times. So now I'm at a point where I have to say, okay, what is it per, if it's 1 pound equals, it cost me $8.50, how much does 9 pounds cost? And that's where this comes into play. Then multiply to find the cost for 9 pounds of salmon fillets. So now we're going to multiply our cost times 9 and our pounds by 9. 1 times 9 is 9. And then 8.5, or $8.50, times 9. Remember, we line up the digits in a situation like this. 9 times 5 is 45. 9 times 8 is 72. Excuse me. Plus 4 should get me 76. I have 1 decimal place, so I'm going to move from here over 1 time, and I should come up with 76.5. So my answer will be the chef will pay $76.50 for 9 pounds of salmon fillets. I just want to mention too, before we move on to practice problems, what you're doing right here. You have a ratio table. And we did really simple ones in the last section in 5.2 at the beginning, finding equivalent ratios. We're finding equivalent rates, but this is technically a ratio. 51 to 6, 8.5 to 1, 76.5 to 9. Those are equivalent ratios, and we're just using it to model a rate at this point. So you can always check, does 51 to 6, is it equivalent to 8.5 to 1? And you can check that with using fractions, if you will, and it will work out and they will be equivalent. So just remember that we're just building upon what we've learned. I'm not going to do example B because I have a note in my book that last year this was extremely confusing. If you would like to review it to see if it's a better way, I don't want to confuse anybody, but I don't mind going it over with you if you really feel like this is a better option for you. So review it on your own. If you feel like it's something you need to do, please do so. The rest of the video will be, your next slide will be your practice problems, and then from there I will go over a couple of the on your own. Okay, your practice problems for your twirl discussion is from Big Green, pages 208 to 209. You have number 4, and I just wanted to kind of review here. Number 4 is from example 1. Number 7, 9, and 13 is from example 2. And number 17 and 23A is from example 3. Please note, you don't need to do B. I didn't do B for your example 3, and that's the exact same thing. So don't get all confused when you're like, I didn't know how to do B. You don't have to do it. Okay, and then if you'd like to stay tuned, I'm going to do a couple of the on your owns just for some extra practice. Alright, so the first one on page 207, the on your own, it was write another rate that represents the situation in example 1. I went over all of those, so I didn't think that was a big one to go over. So number 2 I started with. It says a Japanese bullet train travels 558 miles in 3 hours. How far does it travel every hour? What you need to realize, let me get my pen out. You need to realize that you're finding a unit rate, and how you do that is you say, all right, so if it travels the 558 miles in 3 hours, how far does it travel every hour? Those are your key words. So you need to construct this ratio table to figure out how many units it is, or how many your 1 unit rate would be. So in other words, I pulled out the word travel, and we talking about how long it travels in miles. So I used travel, and we did that in miles. It's 558 miles. Time I got from the 3 hours, and we know it's represented in hours, it's not minutes. And they're talking about 3. So now we have to figure out, how do I get to 1? And so we know that we're looking for the unit rate. If I went from here to here, how could I make 3 into 1? Well, you divide it by itself, divided by 3. So I'm going to do the same thing up here, divide by 3. Again, I'm not expecting you to know that off the top of your head, so if you have to write it out, 558 divided by 3. 3 goes into 5. 1, oh, I'm going to get my pencil back, sorry. 1 time, 3 times 1 is 3. You have 2 left over. Bring down your 5. 3 goes into 25. 8 times. 3 times 8 is 24. 1 left over. Bring down your 8. 3 goes into 18. 6 times. 0 left over. So my answer for number 2, or when I divide this out, should have been 186. So your answer, you could say, is 186 miles per hour. How far does it travel every hour? 186 miles would be your final answer. Okay, so number 3 says you pay $8 for 16 ounces of sliced turkey. Write a rate that gives the price for each ounce of turkey. So we need to look at this and realize that if we have 16 ounces, we're paying $8. We want to know the price for each ounce. So you're doing the same thing. You're finding a unit rate. The best way to represent this is using a table. But to figure out your table, you need to figure out what your wording is going to be. Well, I've got ounces and I've got money that we're paying. So you can start off with saying ounces, and we can do one that has dollars. So we do 16 ounces for every $8 that we have, and then you can make a table out of that. We want to know write a rate that gives the price for each ounce of turkey. So now we're trying to find how we get to an ounce of turkey. Be careful, it's not always a lesser number that you're dividing out. We want to know what 1 ounce of turkey equals. So to get from here to here, you divide it by 16. So that means I have to do the same thing here. Divide by 16. Well, I told you before, you can have it and do it as a fraction, but be careful because this asks for, let me get my pencil back here, the price. Well, you're not going to tell me it costs 8/16. What does that mean? So you have to figure out that price. And in order to do that, you need to divide it. So you need to say 8 divided by 16. Well, 16 doesn't go into 8 evenly or at all. It goes in there 0 times. 16 times 0 is 0. I have 8 left over. No numbers represented creates a decimal that you put straight up. Your 0 goes here, and we go down. So now my 0 is here. How many times does 16 go into 80? Well, it goes in there 5 times. It goes in there evenly. 16 times 5 is 80. So now I have 0.5. What does that mean when we're talking money? 0.5 equals, that's when we add on that 0, and if we have half of, which is what this is, that means we have 50 cents, right? And it's written like this. So I would put over here, I have 0.50 or 0.5 in this case. So my answer would be, write a rate that gives the price for each ounce of turkey. It would be 0.50, so 50 cents per 1 ounce. And you can put O-U-N-C-E too if you want instead of putting the O-Z. And this would be your final answer because I wrote it as a rate. Alright, so those are all the on your own, excuse me, all the on your own that I'm going to complete at this time. If you still need extra practice with this, let me know so we can kind of get some more idea. I can get some more idea how to help you and whatnot. And let me know any questions that you have. Good luck.